Hello all, good morning. Welcome to this Kubernetes session. So today we will be talking about scheduling topic. Okay. As of now we have created a pod or deployment or anything and that goes on to any of the worker node. As you can see in our cluster we have two nodes, and if I create a pod then that pod may go on this worker node or on this worker node. So it was not in our hand to schedule the pod on particular worker node, but that part we can do with the help of scheduling functionality. Okay, and there are multiple ways of doing it, so we will just talk with the very basic way of doing that. Let me open the uh, I mean to say this paint so that we can talk about it with theoretical way, and then we will head over to the practical later on. Okay, so this is our, let's say, a worker node, one worker node and second worker node, and let me rename it as worker 1. This is worker 2. Okay, and let's say if I want to schedule a pod, okay, then automatically this pod may go on any of the worker node, either over here or over here. Okay, it was not in our hand. But let's say if I want to put my pod only on this worker node, this is my requirement. So with the help of scheduling functionality, I can do that. So one way of doing it is as a node selector. Okay, node selector option. There is one option in the pod creation. How does it work? Okay, now you know that uh, we can attach a label to the pod. Okay, like type equal to front end or any label we can attach to the pod. In the same way, we can attach any label to the worker node as well. Okay, so let's say if I attach a label to this worker node as, let's say, size equal to small. Let's say this is the label attached to this worker node. How to attach it, all those things we will see practically. And now if you want to schedule this pod on worker 1, then definitely we have to match that label under the node selector. So within the pod definition we will be writing node selector size equal to large. So if this is matching with any of the worker node, then this pod will get scheduled on that worker node. This is as simple as that. Okay, so this is how a straightforward scheduling we can do with the help of node selector. So let's do it in practical and let's see if it works or not. As of now, if you see Gibbs will get nodes or node hyphen show label. We can see all the labels that are attached to this node. Okay, and whatever labels you can see right now, all are provided by the DigitalOcean. Okay, these labels that are attached to this worker node is not something I have created. You can see digital docs.digitalocean.com node hyphen id. So this is the id, and then pool id क्या है उसका, then node pool क्या है. So all those things are internal settings of this Kubernetes. Okay, and we don't have to do anything with that. We have to create a custom label for our node. Okay, so these labels will be there as it is, and we are going to add one more label to it. So let's say I'm interested in scheduling pod on this worker node. So what I will do, I'll just label this node kubectl label node, name of the node, and let's say size equal to large. Okay, so I have added one more label to this worker node. Let's look into this kubectl get node. So size equal to large I have added, and you can see over here. Okay, this is the size equal to large thing which I have just added. Earlier it was not there. Okay, now a node get labeled the way we used to label a pod. In the same way, we have labeled a node. Now if I want to schedule a pod on that particular node, uh, any pod do we have over here? No. Let's open the pod scheduler thing, and this pod we want to schedule on this. So we are adding size equal to large, a node selector. So this is all about on which node we want to schedule this pod. Okay, pod with nginx image, and this is defined over here. So any worker node जिसका label size equal to large है, over there this pod will get scheduled automatically. Let's apply this. I think we are working in this. Okay, I'll add. I'm not interested in namespace now. This is going created in the dev1 namespace, so I'm not interested in that. And let's say name it as p1. I want everything to be working in the default namespace. So let's apply it one more time. So my pod got created. Actually, last time we have applied certain resource quota to the day1 namespace, so that's why earlier pod was not getting created, but now this got created into the default namespace where I don't have any resource quota defined. So how to check this pod got created on which worker node? So if you check -o wide, then ending with v2 it got deployed. Okay, so I think this is the only ending with v2 को ही अपन ने size equal to large label लगाया था. So that's where my pod got deployed over on this worker node. And the negative thing, let's say what if this pod is saying that I want to get scheduled on size equal to large worker node, but let's say if there is no such label assigned to any of the worker node. I mean to say kubectl get node. I mean to say let's say if this size equal to large अपन ने define तो कर दिया है, but what if there is no such label like this? What is happen in that case? Okay, this can be a tricky one, interview question. So in that case, we have to try this practical. We have to delete the label associated with this pod label. Which label we want to delete? Size. So minus is all about removing the label associated with the size. Okay, so size minus means size equal to large जो मैंने label लगाया था, that is getting detached now, unlabeled. So I don't have any label associated size equal to large. ऐसा कोई अभी label नहीं है. If I do show labels, you will not see any label as like size equal to large over here. Okay, now let's try to recreate this pod. So delete pod p1, and let's try to apply it again just to see the effect. Now you can see the status of this pod is pending. It's not into the container creating or running, because this pod is trying to be scheduled on a worker node having label size equal to large, and if there is no such label associated, in that case my pod will be into the pending condition, pending situation. if I just want to check the description related to the pod, then you can see 0 out of 2 nodes are available, means there is no such a node with matching labels. Didn't match pods, node affinity or selector match nahi hua, and that's why scheduling is not happening over here. And once you attach that label, okay, now you know this pod is into the pending condition, and you got to understand why it is into pending condition. Then in that case, let's say once you attach the label to that, I have done the control C. Once you attach this label size equal to large, again after creating the pod, then definitely my pod will go into the running condition. You can see now earlier it was pending, but once it find it out, it will keep on searching for a respective worker node with a perfect label match. Okay, if that happens in future, definitely this pending situation will go into the container creating, and definitely it will go into the running as well. Okay, pending means it is just waiting for a worker node, nothing else. Understood this topic? What is node selector over here? Now there is one drawback of having this node selector over here. What is the drawback? That if this size equal to large, uh, it's associated, let's say, with this worker node. Okay, and definitely this pod will get deployed over on this worker one. Let's say now due to some reason this worker node crashed. Okay, and let's consider this pod was created with a deployment or a replica set. So automatically what is going to happen, this pod, the pod that was over here with node selector as size equal to large, will try to recreate on this worker node. Okay, but this worker node is not having this size equal to large label, so definitely again that pod will go into the pending condition. So that is one of the drawback that we have with this node selector option. So what are the means how we can overcome this situation? Let's say there are three worker nodes. Let's consider a scenario. We don't have three, but let's consider a scenario where we have three worker node. So one is size equal to large. Let's say one is size equal to medium, just for understanding. This is worker 3 with size equal to small. Okay, so let's say these are the labels I have attached, and the way I am making use of this, let me make you more feel better over here. Let's say the resources that are assigned to this resources to this are little bit smaller, and this is even smaller. I mean to say this first worker node is having 4 CPU, second worker node is having 2 CPU, and third worker node is having 1 CPU likewise. So that's why I have drawn the diagram like that. Now to overcome the previous scenario or the disadvantage of node selector, we have node affinity now. Okay, what is meaning of that? It's similar to node selector only, but there will be one more option in case of the node affinity. In that case, I can write within the pod that please schedule it over size equal to large or size is equal to medium. don't schedule it on the size equal to small. Okay, so I can have the condition like this. Okay, try to schedule it over the size equal to large worker node or size equal to medium worker node, but let's not schedule it over the small worker node. So that kind of you can say a condition I can put over the node affinity. It was not possible with a node selector. Okay, so even though if my, let's say, pod got with the help of deployment, let's say a pod got created over here, and due to some reason this got crashed, then definitely this pod will try to go on this or this, but size equal to small पे नहीं जाएगा because the label is not matching with the node affinity over here. So that's where this is not possible. Size equal to medium is definitely possible because it's mentioned under the node affinity. So having multiple choices for a worker node to get it deployed means for a pod to get it deployed, it's possible with the help of node affinity. Okay, understood this, like what is the difference between node selector and node affinity? And now let's do it practically. In that case, what how does it work? Meanwhile, let me just have this kubectl label node size equal to large. Similarly, let's have one more kubectl label node. Let's label second one as well. Size is equal to, let's say, small. We have two nodes only, so we will play with two only, so not an issue. Now let's delete the previous pod, and this node selector will get removed with the node affinity. I don't remember exact code for the node affinity, so I'm definitely going go to this Kubernetes documentation, or you can see a notes which I already took. In that case, let's make use of this section affinity. Let's add this content. Okay, so what I have done, I have added this affinity content over here, and this is a node affinity type. And just understand this, okay? Rest you can ignore right now. So on which matching expression it should go, okay? If, as I was talking about that there are multiple options that we can provide. If key is size over here and value is small, medium, large, whatever we have specified. If size is equal to large, or let's say small, then this pod will go, means whatever you will provide over here. Let's say right now if I specify large or medium, okay, if size in large, what does this mean? This is nothing but if size equal to large or size equal to medium, though worker node, so it is like we are having two expressions to match with a label of a worker node. Okay, earlier there was only one expression to match, but now we are trying to match two expressions, so which is a kind of high availability for a pod. So that's where this node selector term, so on which basis a node will get selected, it is all depends upon if this matching or not. Okay, so right now we don't have any worker node with size is equal to medium. We have one large and one small only, so definitely it will go on a worker node having label size is equal to large. Okay, So this expression is much more important to understand what does it mean. Rest is like you can say a default expressions or default content that you have to write. But let's understand this first. So let me create it. I'll explain this as well later. So pod got created and it got created on size is equal to large, and I think I have attached size is equal to large. Yeah, size equal to large attached to this, small attached to this. Okay. So it should go to the AV2. Okay. Definitely. And what if I just change this to size equal to small, then it will go to the second worker node. Okay. But what if okay, let me show you first. It got created, it should go on to the second worker node. So it has gone to the second worker node successfully over here. This is how you can just switch this pod between one worker node and another worker node and multiple worker node definitely. And to get a benefit of this, definitely you should have three or more than three worker node, so that you can play with it very easily. But we are having only two, but the condition or the, I mean to say, the logic will remain the same. It doesn't matter you have 4 or 5 or 6 worker node, but the logic which we have just discussed, that will still remain the same. Now what is the meaning of this? Required during scheduling, ignored during execution. It means whenever this pod is this is like a formation of two messages you can consider. One is required during scheduling, which is the highlighted one. So what is the meaning of this? Whenever a pod P1 will get scheduled, so this requirement should be matching. Size is equal to small, size medium, small, whatever might be the thing, it should match. So whenever a pod will try to schedule, this is mandatory. So required during scheduling. And ignored during execution means, let's say, uh, ignore during scheduling means, let me show practically. Now let's say kubectl will get pod, you know that this pod is scheduled on this second worker node. And what if the, after scheduling the pod, what if the label gets removed or detached? Okay, let me try out that as well. For the second worker node, let me remove the label. Okay, इसका label मैंने निकाल दिया है. Still you can see pod is there, there is no impact. But only thing, now onwards P1 pod will not go over this, but अभी जो मेरा P1 pod है, that will still be intact. क्या बोलते हैं, लेबल निकालने के बाद pod वहाँ से गायब नहीं होगा, it will be there as it is. So that is the meaning of ignore during execution. If you remove the label after scheduling, that will get ignored. So Kubernetes will not take care of that. The state of the pod will remain the same. That is the meaning of this. Main thing आपको यही देखना है कि what is the difference between the node selector and node affinity. So in node selector only one label is possible to provide, but in case of uh, node affinity we can provide multiple labels. The way we have provided operator in, there is like not in as well, like not in, then there is parameter like exist. So there are different parameters, but the not in matlab size should not be small, size should not be medium. All the other worker nodes are possible, but definite like size equal to small and medium nahi chalega if you are making the not in. Okay, that is the meaning of this operator. this is the one thing. You guys understood now the difference between the node selector and node affinity, and when to use which one, what are the benefits of node affinity over node selector. So let's talk about one more interesting part within the scheduling, that is nothing but the taint and toleration. Okay, so there are only three ways of doing scheduling. One, we have discussed about a node selector. Second way, we have discussed about node affinity, and third way is all about a taint and toleration. This is quite interesting topic and kind of logical as well. Now let's say we have one worker node, second worker node, and third worker node. Okay, what will happen in case of taint and toleration? Okay, taint and taint is provided to the first of all, understand taint is similar to one of the label. The way we used to attach labels to the worker node, in the same way we can attach taint to the worker node, and it's a kind of another part of the label, or you can say similar to label. What if this pod, let's say अभी मैंने टेंट लगाया है इस वर्कर नोड पे, color equal to red. On this worker node, if I attach color equal to blue, and on this worker node, let's say I have attached color equal to green. Okay, now, and these are all taints. Okay, understand. And worker 1, 2, 3. If I want to attach, if I want to schedule a pod, the thing is, in case of the node selector or node affinity, if I define over here like node selector equal to size large, in that case definitely if this pod is looking for a worker node having size equal to large, and if it is found, it will go on that worker node, otherwise it will not go on that worker node. Okay, but one more thing that is associated with node selector and node affinity is, let's say if you don't define any node selector over here, okay, on the pod level, and still you are having the labels. Okay, पहले pod को label attach किया है size equal to large, small, medium, then that label is of no use. So node selector and node affinity में priority किसको है? pod को है कि वो कहाँ जाना चाहता है. मतलब if there is no node selector defined, then that pod can go on any of the worker node irrespective of their labels. So that's where node selector अपन लगाते हैं just to define on which worker node it should go. So यहाँ पे मतलब pod के हाथ में ज़्यादा प्रायोरिटी होती है कि उसको कहाँ schedule होना है, if we are defining node affinity or node selector. And in case of taint and toleration, नोड के ऊपर ज़्यादा प्रायोरिटी होती है कि उसको कौन से पॉड एक्सेप्ट करना है एंड कौन से पॉड डिनाई करना है. इट मीन्स, let's say if I have tainted this pod, sorry, tainted this worker node as with a string color equal to red, blue and green, and let's see if I don't define anything, means if I simply create a pod without any node selector, node affinity, without any toleration, nothing, simply I just create a pod. In that case, this pod will try to go on this worker node, but as this is tainted, so it will allow only those pods which are matching with toleration. Earlier we were using the node selector for matching this label. Now we will be using toleration over here. Toleration, we will attach toleration to the pod. What kind of toleration we will attach? Let's say I will say color equal to, let's say blue. I'll say within this pod definition I will write this toleration color equal to blue, let's say. Now if this pod try to be deployed on this, then definitely this is not matching. Color equal to blue and color equal to red is not matching, so this is not possible over here. Again this pod will try to go to this worker node. एक काम करते हैं, थोड़ा चेंज करते हैं so that things will get pretty much understood. Let's say इसको कोई टेंट नहीं है and this is having tent as color equal to blue. Okay, so understand at which in which situation pod will go where. So first it will try to be placed on the first worker node. Definitely it's not possible because tent and toleration conditions are not matching. One is saying blue color, another saying red color. Then this pod will try to go on this worker node where there is no tent defined. So in that case pod will get placed over here, because as I told you, in case of tent and toleration the priority is given to the node that whether I should accept or not. And on this worker node uh, nothing is mentioned related to the tent, so this toleration is also get nullified, because this toleration is important only when there is a tent attached to the worker node. So definitely pod will go over here. And what if in this condition there is some uh, means I mean to say, let's say there is, let's talk about this scenario where is this. Okay, now let's say again let's start with scratch. Pod will try to go on this worker node but not possible. Pod will try to go on this, then it will be accepted because toleration and tent is matching over here, so it will go over here. So this is how a scheduling will happen in case of tent and toleration. Why we are using this? Because in this case a worker node wants to collect a pod, or worker node wants to get pod to be get scheduled on a worker node of the similar type. मतलब मिडल वाला जो वर्कर नोड है उसके ऊपर ऐसे ही पॉड आएंगे जिसका टॉलरेशन कलर इक्वल टू ब्लू होगा. Otherwise definitely this color equal otherwise pod will not be accepted. Okay, so again if I try to deploy the color equal to blue pod, definitely it will not go on to the first, it will not go on to the third as well, because our tent and toleration is not matching. So again pod will get scheduled over here. So this middle worker node will have all the pods with matching toleration, otherwise pod will not get scheduled over here. So if you want to collect all the pods of similar type, definitely this tent and toleration is important over here. And there are three conditions that are along with a taint. Okay, which all three conditions that are provided in taint and toleration. This is kind of a destructive behavior. Okay, I'll show you. You can say condition or you can say effect. One effect is like no schedule. Let's say color equal to red colon no schedule. ऐसे थोड़ा स्टार्टिंग से लिखते हैं so that things will be easy to understand. So if you want to define tent, you have to define like this: color equal to, let's say, red. This is the effect, okay, and there are three types of the effect. One is like no schedule simply, third is like prefer no schedule, sorry, second is like prefer no schedule, and next is like no execute. No schedule is like simply let's try to match this color equal to red with this toleration. If this is not matching, then it will not allow to schedule. सिंपली जैसे पहले हो रहा था, मैच नहीं होता है तो schedule नहीं करना है. So that is the meaning of no schedule. Prefer no schedule, it means uh, let's say this is having something else, let's say white, and this is white and nothing sort of that. And let's consider a scenario where toleration equal to color equal to white, and in this condition if I say color equal to blue colon prefer no schedule, okay, I mean to say if I write this or if I provide this taint to this middle worker node, so in that case what is going to happen, and same goes for this as well, like no schedule. Let's say these are the conditions or these are the taints that I have attached to these worker nodes. So in this case what is going to happen, this pod will try to go on this worker node, okay, this pod will try to go on this worker node, but definitely not possible because color equal to red and color equal to white are two different things. So that's where this is getting checked. What is the effect now? Effect is no schedule, so this worker node will not allow to schedule the pod. Let's say if this pod goes over here, color equal to white and green are two different things, and then effect is evaluated, so over here as well it is not allowed to schedule. Then let's say if we try to come to this worker node and it is saying color equal to blue and color equal to white are two different things, but as there is no other place for this pod, मतलब कोई चौथा worker node नहीं है जहाँ पे वो जा सकता है, there are only three worker nodes, so this pod is not having any other option. So that's where it is a kind of polite behavior, ठीक है, if you don't have any worker node to schedule on, then I'm okay to allow you to schedule. So that's where even if this color equal to blue and white are not matching, but this effect matters a lot. Prefer no schedule means prefer not to schedule the pod, but if that pod is not having any other option, in that case uh, it will allow to schedule the pod. So that is the meaning of that is the difference between no schedule and prefer no schedule. Third is no execute, but before going over there, I just wanted to know from your side that are you guys getting what I'm trying to say over here? Let's say I hope we are clear with this no schedule and prefer no schedule thing. Third is like no execute. It's very much risky to use this no execute. Okay, what is the meaning of this no execute? Uh, let's say if I specify this color equal to blue, okay, so definitely color equal to blue will come over here, and earlier there was this, let's say, colon no schedule. This was the earlier taint attached to this worker node. So that's where color equal to blue match हो रहा है, so that's where it is going to take this, keep this uh, pods over here. Let's say एक आधा pod रहता है जिसका color equal to red आता है, तो that color equal to red वाला pod यहाँ पे आ जाएगा. एंड कलर इक्वल टू ग्रीन वाला पॉड यहाँ पे आ जाएगा. सो सेग्रीगेशन हो रहा है. व्हाट इफ आई रिमूव दिस color equal to blue, no schedule, okay, entirely. Taint I can remove as well, like after applying the taint. Similarly I can remove the taint as well. So if I remove this taint, this pod will still be there. Okay, there is no problem with that. This pod will continue to be up and running. And if I provide one more taint to this, like new taint to this, let's say color equal to gray colon no execute. Okay, you will understand the difference between this now. A new label, let's say I have provided color equal to gray no execute. What is happening in that case? This no execute is very destructive one. It is going to keep only those spots on this worker node जिसका color equal to gray है. But earlier ये दोनों pod का क्या था, color equal to blue था, and it was up and running. But now if I apply this taint or attach this taint color equal to gray no execute, then definitely it's not matching with this existing pod toleration. So these two pods will get deleted from this and will try to shift on another worker node. So no execute is kind of very destructive over here. It will keep only those pods having color equal to gray. Rest all pods it will destroy. It will get destroyed from this worker node and it will get scheduled on somewhere else. Not definitely on the not on the middle one. So basically, let's do in all those things in practical to understand this. We will just stretch maybe 5-10 minutes more to wrap up this topic. So as of now, if I show you kubectl get node, we have two worker nodes. If I describe it, describe node first one, and if I just show you the description about this, you will get some idea about a taint over here. Let me just describe like this. Taint as of now none. Okay, so there should be some location where taint is mentioned. Over here you can see taint equal to none. So there is no taint associated with this. Similarly for another worker node, kubectl describe node this taint. As of now there is no taint associated with that. So let's attach a taint to the first worker node. Taint node, let's see if I attach color equal to red no schedule. Okay, color equal to red no schedule मैंने attach कर दिया टेंट, and once I attach the tent I'll get that information in the description that I have attached it. Okay, this is the tent which I have attached. Now if I try to create any pod, let's say kubectl run p1 nginx, let me delete this pod p1 and let me recreate it. Now you can see this pod p1 is not scheduled on this worker node. It got scheduled on some other worker node. Okay, why? Because there is टेंट over this, so इस वर्कर नोड के ऊपर ऐसे ही पॉड आएंगे जिसका toleration is matching with the tent. But while creating a pod, I just simply created without any toleration. So that's where pod got created on another worker node. So if you create any other pod without any toleration, definitely pod will not get created on this worker node with the help of no schedule. Okay, so what if how to define toleration? That is one more question. So let's try to go into that toleration section. Let's say delete this pod. Let's write the toleration code. So I'm trying to create a pod with a name as, let's say, p1 again, with nginx image, keys like color, values like I said red. Okay, so color should be equal to red and effect should be no schedule. It means whatever things I have specified in the taint is exactly matching over here. Okay, color equal to red, effect is also no schedule, so each and everything is matching over here. So that's where there is of high chance that p1 will get scheduled on the first worker node. Okay, now you can see it is still getting placed on another worker node. I mean to say, as I said earlier, that there are chances of going that pod on the first worker node, but still it is going to the second. Why so? Because second worker node पे कोई taint नहीं है, so second worker node will allow all the pods. But if this pod internally try to go on the first worker node, definitely that pod will get scheduled. So what we can do, we will try to create one more pod. Likewise, let's try to create 3-4 pods. So let's try to create one more pod. Likewise, with name as p3 and apply it. You can see one of the pod goes to the uh, first worker node as well over here, because it was exactly matching. If you describe kubectl describe pod p2, you will get to see some extra information that this is the toleration that I have attached to this pod, and it goes on to this worker node because it's exactly matching. I mean to say, uh, taint and tolerations are exactly matching over here. So that's why it is possible to shift that pod on this worker node. Okay, let's understand the no execute now. Now you know kubectl get pod. We have attached taint to this first worker node. Okay, let's remove that taint. Kubectl taint node. How to untaint it? There is one command to untaint it. Let me check once. There is option of removing the taint as well. Okay, entirely we have to provide color equal to red, no schedule, minus. Okay, minus is like you are removing the taint. Okay, no schedule का spelling मैंने गलत दिया. S should be capital over here. And let's provide minus as well to remove it. Okay, so I have removed this taint which was attached to this, and still pods are up and running. But what if I attach a taint to this with no execute? In that case, no execute, okay, color equal to red ही लगाया मैंने, so this pod p2 pod will still be there because toleration, okay, that is not matching. So what is happening over here in pod a YAML file, what I have written color equal to red and no schedule, but right now I am writing color equal to red and no execute. So that's why जो pod p2 बनाया था मैंने, that got deleted because that was created with simply the pod, not with a deployment or not with replica set. So उसके जगह पे कोई नया pod नहीं बनेगा. The pod p2 got deleted automatically because there is no, I mean to say, like that the worker node on which it was running, that is not allowing it because of this no execute effect, you can consider. So I hope now you understood how it works internally, means the difference between no schedule, prefer no schedule, node execute, sorry, no execute, with the help of this practical. So now you guys know how to taint a worker node, any worker node with any of the effect, and how to provide a toleration with matching taint, and the difference between these three. Okay, that's all I wanted to share in this session. How about Madhuri?